Next topic that we want to have an example of is what we mean by arc length, and in particular how that relates to the parameter t. Okay, so to look at this, the first thing we're going to look at is two trajectories. A circle in a counterclockwise direction of sine t, cosine t, sine t as t goes from 0 to 2 pi. And the second one, R2, is also going to be a circle in the counterclockwise direction, but is going to move twice as fast, cosine 2t and sine 2t. I'm going to restrict its parameter to 0 to pi. So it goes half, the value of the parameter is half, the speed is twice. So now what I want to look at is how that relates to the value of the parameter. So in other words, for number 1, is that what I want to do then is compare the value of t, which is going from 0 to 2 pi, to the length of that trajectory. Now R1 as I go along. So as the parameter goes from 0 to 2 pi, the curve goes from 0 to 2 pi. Whereas in number 2, the value of t is only going to go from 0 to pi, in other words, half the distance, but the length of that trajectory is going to go all the way around the circle to 2 pi. So you can see that here there's a mismatch, that I don't, every unit that I go, so say that I just go some little piece of dt, I'm actually going to have to go a much different length when I do the length of the trajectory. So they don't match. So if we look at that arc length formula that we had, S of t is the arc length, is the integral from a to t of the square root of those derivatives, right? So I'm going to use a dummy variable to keep track of all my derivatives, and h prime squared, and then du, so that we recognize this expression again as the velocity, so that I can really write, the magnitude of the velocity rather, so that I can write that that arc length is the integral from a to t of the magnitude of that velocity du. Okay, so we've connected now the value of the parameter in the limit of the integral, right? So that's our parameter. So we've connected it now to the arc length. Okay, that's very useful. So now we can determine how these two relate. In particular, if we want to take this idea of trying to figure out how much of this arc length is traversed for each change in the parameter. In other words, if I take a small piece of arc length, and then I'll call that ds, and then if I take a small piece of the parameter, a delta parameter, and I'm of course going to call that dt, is that I can write this as, use the expression here, and write that as ds, let me take that off of there, d of dt, and then put in my expression for s in the integral from a to t of the magnitude of the velocity du, magnitude of the velocity du, and I end up, right, remember that the derivative and integral inverse operations. So when I do this whole integral, I end up with this magnitude, and I can write that ds dt is equal to the magnitude of the velocity. Okay, so that's an important idea here, because what we have done is to take this change in arc length, right, so our ds, and say, well, if it's going to go 1 unit for each value, then my length of arc is also going to go 1 unit for each amount of change in the parameter, right? So that the big concept is what we want to get here and try to be able to determine how we know that the parameter corresponds to arc length, is that if we say that if that magnitude, when we compute it, equals 1, then just a quick idea about, well, here's the arc length formula, integral from a to t of the magnitude du, and that I can write that as 1 du. And so I find out that I'm just moving along. Here's my origin, right? That's the bottom of my integral. And then I'm just moving along that curve 1 to 1. All right? So if I just take a quick example and say that, let me just take this vector r as a simple 3-dimensional vector, t over root 3, t over root 3, and t over root 3. And then ask that question whether this thing is going using parameter as an arc length. So the first thing I need to do is answer this question: does the magnitude of the velocity equal 1? So compute the velocity, and that is just also a 3-dimensional constant expression. and then find the magnitude of that velocity. Okay, so that I'm going to end up with 1 over root 3, the quantity squared, and do that 3 times, and find out that 1 over root 3 squared, find out that that is the square root of 1, which equals 1, right? So since that I computed the magnitude of the velocity, and that's going to be 1, is that I can then conclude that R of t uses arc length as a parameter. In other words, there's no difference between how fast that curve is moving, uses arc length as a parameter. Okay, so that there's no difference between how far it moves in the parameter value and on the arc. That's the important part.